In this video, we'll explore the use of an important tool called theoretical probability. Let's recall that an event is the result or outcome of a probabilistic experiment. For example, what are all the possible outcomes of rolling a single six-sided die? Well, a six-sided die has the sides of values 1, 2, 3, 4, 5, and 6. So this is going to be the set of all possible outcomes. We usually call that capital S for sample space. We have two main ways of determining probability. The first one is experimental probability, which we compute using data. For example, if we want the probability of an event E, what we do is we take the number of times that event occurred and we divide that by the total number of trials of the experiment. To compute theoretical probability, we need each outcome to be equally likely, like if we're rolling a fair die. And then we can compute the probability of an event E as the number of ways that E can occur, out of the total number of possible outcomes. Let's look at an example of using theoretical probability. Here we have that a single fair die is rolled, and we're supposed to find the probability of the event rolling an even number. Let's write out the possible outcomes for E. We know that 2 is an even number, as is 4 and 6. Those are going to be the only three possibilities for rolling an even number on a single die. The set of all possible outcomes, or the sample space S, is going to be 1 through 6. And so to compute the probability of E using theoretical probability, we'll take the number of outcomes in E, which is 3, and divide that by the total number of possible outcomes, which is the size of S, or 6. This reduces to 1/2, but we usually write probabilities as a decimal value between 0 and 1, so this can also be written as 0.5. So this is a 50% chance of rolling an even number. In this example, a bag of candies contains the following flavors, and we're supposed to assume one candy is drawn randomly. So over on the left we have this table. We have 4 strawberry candies, 2 cherry, 6 grape, and 8 lime. And we're asked, what is the probability that a grape-flavored candy is drawn? Now, assuming that any individual candy is equally likely to be drawn, we can use theoretical probability and compute the probability of drawing a grape-flavored candy by taking the number of ways that we can draw a grape-flavored candy, there are 6 of them, over the total. Now, when we add this up, we're going to have, 4 plus 2 is 6, plus 6 is 12, plus 8 is 20. So we'll have 6 over 20. We can reduce this to 3 over 10, which is 0.3 as a decimal. In the second one, we're asked, what is the probability of drawing a lime or a strawberry? So we need to compute probability of lime or strawberry. In order to compute this, we need to count how many ways there are to draw either a lime or a strawberry. There are 8 limes and 4 strawberries, so that would be a total of 8 plus 4, which is 12, over 20, which is the total number of candies. We can reduce this to 6 over 10, which becomes 0.6 as a probability. Let's check for understanding. Work this one out on your own and then come back and check your answer. This says that the following spinner is at a carnival. If it is equally likely the spinner lands on any one of the regions, what is the probability of winning something? Rounded to decimal places. When we look at this, we see that there are only 2 ways to win. There's a stuffed animal and cotton candy. The other 4 regions have no prize. So E, which is the event win something, only contains stuffed animal and cotton candy. So the probability of E occurring is going to be the number of ways E can happen, which is 2, divided by the total number of possible outcomes, and we have 6 regions. So we have 2 over 6, which is 1/3, or we could write this as a decimal as 0.3 repeating. We're supposed to round this to 2 decimal places, so looking at the next decimal place, we see that we need to round down to 0.33.